Hi everyone, welcome back to my YouTube channel. And today we'll be embarking on the Forage data science job simulation. The link is in the description below. Kindly click so that we embark on this journey together. Alright, don't forget to hit subscribe and like the video. Thank you. Let's begin.
We are so excited to have you here with us. Yeah, excited to be here. So our role, you are a data science graduate at Lloyd's Banking Group. Oh, exciting. You're part of the data science and analytics team, where each member contributes uniquely to projects. The team has been assigned the task of enhancing customer retention through analytics, focusing on predicting customer churn. Oh, exciting stuff. Uh, As a recent graduate eager to apply your data science skills, you see this project as an excellent opportunity to make a meaningful impact. Indeed. So let's go on. The goal is to collaborate with the team to gather and analyze data relevant to customer churn. And then we will need to perform exploratory analysis to uncover patterns and insights and clean and process the data, and then build a predictive model for customer action. Also, additionally, we are expected to suggest ways to evaluate and measure the model's performance. Interesting. So yeah, there you have it. We are basically analyzing a data set that will be given to us, and then we will build a predictive model and then evaluate the model's performance. Sounds easy enough? Let's go. All right, so what they are basically asking us to do is to get the data. So we would be pulling chain related signals and demographics, maybe product usage, complaints, and whatever. We'll be pulling that. And then we'll be performing exploratory analysis, EDA, and then EDA to find who churns, when, after what, the patterns, the trend, the weird stuff, visuals, and then we'll clean the data. We'll try and we'll look out for missing values, outliers. We'll encode, we'll scale. We'll not be using any dirty data. And then we'll go ahead to build the model. So we'll start simple, maybe a logistic regression, and then move to complex models like tree-based uh, tree-based models. And we'll compare them, we'll see which one fits better. And then after that, we'll evaluate through think confusion matrix, precision recall, ROC, AUC. Yeah. And then we'll sum everything up to do the business translation. So who is at risk and what should the bank do about it? So we'll be generating insights that executives can act on. So we are a data science and analytics team at Lloyd's Banking Group, and we leverage advanced data analysis techniques to provide actionable insights and predictive models that enhance customer retention and drive business decisions. Who are we? Well, I'm Edmund. I don't know who you are, but I'm a data science graduate. I will take on the responsibilities of a new hire in the data science and analytics team. I'll focus on gathering and analyzing data, performing EDA, and building predictive models to improve customer retention. And then my team, Lee, a senior data analyst. Whoosh. Lee is a senior data scientist who leads the data science and analytics team, providing strategic direction and guidance on projects that leverage data to enhance customer retention and drive business values. Okay, so projects briefing. Welcome to the data science and analytics teams at Lloyd Banking Group. As a new data science graduate, I have been entrusted with a critical project that could significantly impact our customer retention strategies. Lee, our senior data scientist, has specifically chosen me to take over this project due to my strong analytical skills and enthusiasm for solving real world problems, business problems. This is an exciting opportunity. This is an exciting opportunity for me to apply my knowledge and make real impact. Wow. Okay, so here we're looking at context. I, the project we are about to embark on is the customer retention enhancement through predictive analytics initiative. This project arose from an urgent need to address declining retention rates within segments of our customer base. Over the past few months, we've noticed a worrying trend of increased customer churn, particularly among young professionals and strong business owners. This poses a substantial threat to our market position and long-term profitability. Our fictional client, Marsbank, a subsidiary of Lot, has reported that a substantial portion of their customer base is at risk of moving to competitors offering personalized banking solutions. Smartbank has tasked our team with developing a predictive model to identify at-risk customers and propose targeted interventions to retain them. Nice, 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 nice. So before we begin, it is essential. Before we begin, it is essential to understand a few key concepts. First, customer churn. The process by which customers stop doing business with a company. Identifying and preventing customer churn is crucial for maintaining stable customer base. Predictive analysis. Technique. Predictive, predictive analysis. Techniques that use historical data to forecast future possibilities. In this project, we will use predictive analysis to predict which customers are likely to churn. Exploratory data analysis, EDA. That is a method of analyzing data sets to summarize their primary characteristics, often using visual strategies. EDA is crucial for understanding the data before building predictive models. Machine learning models. They are algorithms that let computers learn from and make predictions of decisions based on data. We'll be building a classification model to predict customer action. So projects requirements. Our task involves two main phases. Phase one, that is gathering and exploratory data analysis. Phase one, that is data gathering and exploratory analysis. Our objective is to collect relevant data, perform exploratory analysis, ED, and prepare data for modeling. So we will identify and gather data from provided sources relevant to predicting customer churn. We will conduct the EDA to understand the data and identify key features, and then uncover patterns and insights. Then we will clean and pre-process the data to ensure it is ready for model building. So our deliverable, we are to submit a report detailing our exploratory data analysis and key findings, including the cleaned and pre-processed data sets. And then we move on to phase two, which will be building the machine learning model. So our objective is to develop a predictive model to identify customers at risk of churn and propose ways to measure the model's performance. So first of all, we'll choose a suitable learning algorithm for the classification task. We'll then build and train the model to predict customer churn, and then we'll suggest ways to evaluate and measure the model's performance to ensure its reliability and accuracy. And the deliverable is to submit a report including the trained machine learning model and your proposed methods of evaluating and measurement of the model's performance. Importance of this project. So addressing customer churn is critical for maintaining smart banks' competitive edge and ensuring long-term sustainability. The board of directors is strongly encouraging the team to deliver a solution promptly, as timely delivery will help secure our market position and capitalize on opportunities. The team is feeling the heat, but they are also highly motivated and determined to turn this challenge into an opportunity. Our role is pivotal in this effort, and our contributions will be closely monitored by senior management. Embrace this chance to showcase your skills and make a meaningful impact. It's time to dive in and get to work. All right, shall we? So, as we can see, this is the data set that we got for the simulation. You can see that it is a multi-sheet sheet, Excel data set. And it consists of churn status, the customers, and whether or not they have churned, and online activities, how the users behave online, the customer service. This shows this shows how the this shows the friction layers, the interactions, and the complaints. And then we go to transaction history. It shows what the customer does with their money, where and what they spend it on. And then customer demographic. This shows to the customers their age, their gender, the marital status, and their income level. So, first of all, we understand the keys, which is primarily the customer ID. And as you can see, the customer ID is the same throughout the the sheets. So the next logical step here would be to join the sheets into one data set. Then we can do further analysis on it. So we would left join. We will left join the data sheets on the ID. So that's so how the data gets into one. So why left join, you might ask. We use a left join because chain status is the reference table that defines every customer that we care about. And we cannot afford to lose any of the customers during the data merger. What that means is that a left join ensures that all customers in the chain remain in their final data sets, even if they have missing records in the transaction history, customer service, or online activity, which is can be common in banking data. So any other join, like inner joins, would silently drop customers with incomplete data, and probably and this would then introduce a bias and weaken the churn model, while missing values themselves can be meaningful signals of these engagements. So, in churn analysis, preserving the full customer population matters more than forcing perfect data coverage. So, yeah. All right. So let's begin. So, what I like to do when I'm working with multiple data sheets is to create a new sheet where I'll be importing all of the other data from the other sheets into it. So, more like a master sheet. So, I will name it master master sheet. All right. Now that that is done, next I would import all of the data from the customer chain into the master sheet. This is where we'll be working and importing the rest of the data from. Next, we would use a function I like using, the XLOOKUP function, to pull the other data from the rest of the sheets. Why are we using XLOOKUP, you may ask? So we are using the XLOOKUP because it allows us to reliably merge data from multiple sheets using a common denominator, in this instance, the customer ID, while preserving all the customers in the database. So, like I explained earlier, we are performing a left join because we want all of the data. We don't want some to be left behind because they have missing data values or inconsistencies. So yes, that is right. So let's do that quickly. First, we'll be pulling the age column from the customer demographics. So we go here and we create the age column. We would edit that later. And then next, we input the xlookup function. I'm sure by now you are familiar with the xlookup function. So the lookup value that we are the lookup value that we want to pull up, that will be the customer ID. And then where we are pulling the array from, each one is matching. The matching values, so this will be the customer ID in the customer demographics. And then the return array. What exactly are we pulling from the data sets if they match? That will be the age column of the customer demographics. And then we include an empty brackets to match the empty data sets just in case. Then we hit enter. So as you can see, we get the first data sets and we just voila, you have all the ages from um, the customer demographics. So we quickly do same for the rest of the column. Oh, shit. Crap. So now Now that we are done with customer demographics, we move on to transaction history. So I'm done importing the other sheets into the master data sheet. So there we have it. All done and all filled. Now the next thing we do is to do a little bit of cleaning because as you can see there are some missing data. So we need to handle that before you can move on to the DED process. All right. All right, guys. So if you remember earlier when we were told the types of data cleaning, when and how to do it, we note some included imputation, imputing, or deleting of rules and stuff. But particular missing fields account for the interruption, where not where some of the customers didn't call customer service. So what I am thinking is that this implies that those that didn't call customer service are satisfied customers. So deleting them entirely would bias the model when we proceed to create it. So this in this particular case, binary flags come in 0 to 1 as to 0 1 customer contacted support, 0 customer never contacted support. So instead of leaving them blank spaces where it confuses the model or removing them entirely, and that also biases the model, we would create a binary flag instead. So let's do that quickly. All right, so what we will do now is to create the binary flag column. So since we are dealing with the empty data sets from the customer service, that means that it depends on whether a customer had an interaction with customer service or not. So with this in mind, I'm going to name my column has customer service interaction. So one will be yes, they had a customer service interaction, and 0 would be no. So here we would write a formula that takes into consideration all the columns in the customer service. And then if they are empty, it will return a 0. Or otherwise, if the rows are not empty, it will return a 1. So let's go ahead and do that quickly.
All right. So since interaction ID is a definite definitive indicator that an interaction happened with customer service, we would anchor the flag to that column only. So we will use this formula, and this works because the trim removes hidden spaces so that empty strings become truly empty. That leaves way for real interaction IDs to return 1. So what you're doing here is that the interaction flag, you are creating it in the presence of a customer service interaction ID. So the blank values that's originated as a form of the left join we did will be treated as no interaction rather than missing data. All right, so now that we are done with the customer service flag creation, we can move into the ED process now. So to begin with, I would first create a new sheet. so that we can do all of the ED calculations over there. I will name it EDA. Okay. So now we can actually start making analysis and the chain prediction. But first, the first thing I will do is to convert our master sheets from a range into a table. This makes calculations in Excel very, very easy if you are working with a table instead of ranges. So just create a table, and that's as simple as that. Then we go back into the EDA sheet. So first, I'm going to create the chain rates. So we know that we will first look at the total number of customers. We just count all non-empty cells using the formula count all, and then we take the customer ID cells, and then we have it. So there are 1,000 total number of customers. Next, we will do the chain rates. So in order to do that, we need the number of people that were actually checked. So those would be the total chain number. To do that, we'll use the count E formula. So we are counting the chain stages. So that's if since one represents chained customers, we count if there's one. If there's one, bring it. So as you can see, there are 204 number of chain customers. That is quite high. And now we can do the churn rates. And the churn rate is simply the total number of churned customers divided by the total number of customers. So we'll pick the number from the total churn cell, and then we divide it by the total number of customers, and then we have 0.204. And then we format it into percentages so that it makes reading more clear. There you have it. So now we have a churn rate of 20.4%. All right, so the next thing to do is to create a churn distribution table. And to do that, we will first need to create a pivot table. So navigate to the master sheets, and then we'll create the pivot table from there. It's highlight the entire sheet and then create pivots. Choose an existing worksheet because we want our pivot table to go into the EDA. Otherwise, we would have chosen a new worksheet. Choose anywhere in the EDA worksheet and then click on OK, and there you have it. We have our pivot table. So we're going to do two very simple things. One, we're going to put the chain status in rows. And then you're going to put the customer ID in values. Then we are going to change the valued field from sum to count as we need individual unique numbers, and then click on OK. There you have it, 700. So the next thing is to display it properly. So change the 0 into retained. These are actual retained customers, and I change the one into churn. And there you have it. Now we will just need to visualize the chain status, the distribution table. So we'll highlight the pivot table, go into inserts and put in a chart. So as you can see, the distribution table is properly visualized. It's showing the number of retained versus the number of churned customers. So then we just need to do a little bit of formatting. We'll size it up. And then we just change the chart title. Just put in something suitable like churn distribution charts, because it is showing the churn distribution. And then just switch off the legend because it's not displaying anything properly. And there you have it. We have visualized we have created our chain distribution table and visualized it. Okay. Next up after the churn overview is where insights actually starts showing up. We'll be looking at churn by customer segments. And here we'll be answering the question, which groups of customers are most likely to leave? Mind you, stakeholders love this section. So first of all, we would be looking at churn by age. So here we would be building a pivot. All right, so here we will be dragging the age into rows. So just disable the chain status and then drag the age in there. You already have the count of customer ID. So what we'll be doing next is to grab the chain status. Yeah, grab the chain status into values. And once again, we are looking at the average of the chain status, not the sum. Alright, so there you have it. You have the average of chain status among the age groups from 18 to I think 65. But to make it clear, we just do a simple format. So we'll change the decimals into percentage. So we just highlight the entire thing. And just change it into percentage. There we have it. So as you can see, the age band is nice. The age is nice because of the because of the many ages we will have. So one thing I like to do when I mix noisy data like this, including numerical data that such as age, is to band them together. So instead of having 18, 19, 20, and so on, we just look at a range, say 18 to 25 or 18 to 27, depending. I will just band them together. So we'll go into the master sheet and then do it there. So yeah, we'll create the age band quickly and then we'll move on.
All right, so now that we have our churn by age, we'll move on to the next churn, which would be a churn by gender. So let's quickly do that. Gender. Alright. So we will just copy this, paste it here. And then instead of age band, we just put gender in there. Then format it as percentage. There we go. We have our chain by gender. And if we want to visualize it as well, we just insert charts. Let's do bar charts this time. We can do the next segment, which would be churned by marital status. Alright, so once again, marital status. Marital status. Just hopefully no. Okay, what the heck? Okay. Alright, so we do same by formatting as percentage. Voila. So we also insert the chart as well. Yeah, I'm also going to do bar chart with this. So there we have it. We have our EDA, part of our EDA done. We'll move on to the next step.
All right, so now that we are done with the demographics block, we will move into the part that actually explains why customers leave. Churn versus customer behavior. Demographics tell you who churns, but behavior tells you why. So we'll be using the flag column that we created, whether or not a customer has interacted with customer service. We'll be using that. So we'll be grabbing that into rows. And then we'll be grabbing the change status into values. And as usual, we'll be going for average. So we change it in the value field settings. And there you have it. Then we'll format it into percentage. So as you can see, 18% of churned individuals didn't interact with customer service, and 21.41% did. All right. So next, we'll be looking at churn by interaction type. So customers that actually interacted with customer service, what type of interaction did they have? This will help us understand where exactly churn is the highest. So we'll drag complaints and interaction type in there, and then format the churn status into percentage. And there we have it. So as we can see, feedback has the highest churn rate with 24.68%, followed by complaints and then inquiry. This tells us a lot as to where the business should focus on in order to prevent customers churn. So most likely the feedback they were receiving, they weren't satisfied with it, hence the high check status. So next we'll dive into if their interactions and complaints were resolved or not. So that will be the churn by resolution status. So moving on quickly, we drag the resolution status into we drag the resolution status into rows, and while keeping the average churn status. Next, we'll be combining the interaction channels. We'll be joining both the interaction type and the resolution status. This will give us a look at the broader picture as to where exactly and why exactly we are having churns across. Alright, so for some reason the filter was on unresolved only, so we quickly switched that back onto Laravel to apply to all of it. So then by clicking on apply, you can see that changes actually come up. So now we can clearly have a look. We can see that unresolved in the resolution status is 22% and resolve is 20. So the 18% out there is just people who didn't have an interaction with customer service and yet they churned. Okay, so now we can see that from the resolved and column, the feedback has the highest churn and rate. So meaning that even though people people's complaints were marked as resolved, they still churned. This could indicate that they didn't like what they were hearing, or most probably they churned, their complaints weren't, or most probably their complaints weren't resolved on their end. And then for the unresolved parts, we can see that complaints were the highest, and that actually makes sense. People complain and their their complaints are not resolved, so they will churn. All right, so the next thing to do is to look at churn versus transaction behavior. Here, we will look at how spending behavior differ between churned and retained customers. So first, we move the churn status into rows and then move the amount spent into values. Here, we'll then switch to look at the average amount spent instead of sum. So there we have it. We have the average amount spent between churned and retained customers. All right. So next we are going to do churn by product category. This section answers which products are most associated with churn. All right, let's start. So we go into our pivot table and then we pull in the churn status into values and then change the field settings to average again instead of sum. All right, and then we pull the product category into the rows. So we go ahead and format the values into percentage, and there we have it. We have the products by their churn rates, and we can see that furniture is leading with over 22%. Next, we will do the churn by online activities. So this uses the login frequency in the online activity sheets. So we are looking at how the number of times people log in and their churn rates. So here we drag the churn status back into values. And then we put the login frequency into rows. Then we go ahead and change the field settings of the churn status into average. Okay, so once again we mix and announcing data that has continuous chain and thereby spreads the actual insight. So what I do is that just as we did for the age where we band them together in ranges, we will do same for the login frequency. So we will do that quickly. To do this, we'll just have to go back into our master sheet and then we create a new column that says login frequency bank. Yeah. And then we input our formula. We input our formula that takes multiple if statements. So what we are doing basically here is that if the value in the login frequency column is greater or equal to 1, if the value in the login frequency column is greater or equal to 1, or if the value in the frequency table in the frequency column is less than 10, then just make it 1 to 10 and so on and so forth. So we quickly do that, and then we come back here, we refresh the pivot table so that the newly created column comes back into the pivot table. As you can see, login frequency is at the bottom. So we go back into the frequency, we go back into the pivot table and disable login frequency and put in the login frequency band instead. And then you can see we have it. So we transform the average of the churn status into percentages, and then we have it. You can see the range of the login frequencies, and this makes it easier to spot insights. So we then move on to the service usage churn. We'll be looking at the usage of the services of the bank from the mobile apps to online banking or websites. So here we drag service usage into the rows, and then we transform the churn status into percentage. Then we have it. We can see that here mobile app is the leading factor when it comes to churn. So yeah, there we have it. Our EDA is all done, and now per the instructions of the task, the next thing to do here is to write a report on what we have done so far. So yes, that's it. So if you made it to the end of the video, congratulations to you. I hope you were practicing along with me and have learned a lot as I also have. Don't forget to hit the subscribe button, like the video, and share it to your friends and your various data analysis groups. And I will see you in the next video where we actually build the churn prediction model with Python. Exciting stuff ahead. Thank you very much. Once again, this is Ed doing data. See ya.